Solve application problems using Euler's theorem. First, let's talk about what Euler's theorem is. And oftentimes, we're using Euler's theorem to solve real-life problems. Now, with this, we talk about a Euler tour, which is basically just a circuit that includes every edge exactly once. So we're not repeating edges. And, a big piece, every vertex has an even degree. So when we see a vertex, it can only have an even number of edges coming out of it. So, let's say that we have, these are all bridges, and a tour guide is trying to create a walking tour over these bridges. Well, you don't want to go over the same bridge twice because that's kind of boring. So can the tour guide create a tour that starts and ends at the same place and not repeat any of the bridges? And in this case for the graph, the edges. Well, as we're looking at this graph, you will notice that vertex H has an odd degree, and vertex E has an odd degree. So we know this is not a Euler circuit, right? We have no Euler circuit because we have, in this case, two vertices that have an odd number. So now, because there's only two, we can create a path that goes over every bridge without repeating, but it's going to end up in a different place. So let's see if we can figure this out. So if I would start at E, right, and kind of follow this along, I can do that, but I'm going to end up at H. So we could start at E, end in H. We're not going to go over every bridge more than once, or any bridge more than once, but we're also not ending up at the same place. So you could be potentially dropped off at one spot for the tour, picked up at another, and that would be the way to figure it out. Now let's pretend we're in a subdivision. This happens, right? It's winter time here where I live. So a subdivision needs to plan a snow plowing route, plowing both sides of the street. Can you create a path that does not repeat edges and ends in the same place you began? Right, so thinking about a snow plow. If we start in one spot, we want to plow both sides of the street and then move on. So if we're looking at each of these, right, so each vertex, two pair of two vertices are joined with two pieces because we're plowing both sides of the street. So you can see that each vertice has an even number of edges coming out of it, so they're all even. So that's a good sign, right? We know that we're going to have a Euler circuit because and a Euler path because every vertex has an even degree. So therefore we can do this, and I want to just show you. So I want to start here at this vertex. If I come here, and then go around the entire subdivision on one side of the street, and then I can come back on the other side of the street, and I end up at the same place where I started. So you can see I don't repeat any edges, end up in the same place, and therefore by Euler's theorem, I can do all of the things, right? Euler circuit and Euler path.